Good afternoon, everybody. Today, actually, I'm going to start the statistical part. Due to busy schedule, and last 1 or 2 weeks, I unable to upload the video related to physics class. We have already made some video related to electromagnetic theory, statistical physics, quantum mechanics, spectroscopy, semiconductor physics. We will upload within 1 or 2 days. Okay. Today, before going to that, today I am going to start the statistical mechanics. We will discuss the remaining part of statistical mechanics and thermodynamical parameter, and which are very important to understand the physical phenomena, thermodynamical phenomena. So, before going to that, and I have seen last 10 year question. Most of the question in case of statistical mechanics comes from the Pathria book. If you study, if you can digest the Pathria book, you can easily qualify NET/GATE exam, because I have qualified many times NET/GATE SLET, and I only follow the Pathria book. Okay, and all my calculation and derivation, numerical problem, all are from Pathria. Okay, today I am going to discuss. After that, I will discuss. So entropy. Yes. What is the value of entropy? What entropy measure? Entropy meaning disorderliness of a system. Okay. Suppose if we consider a system of n particles, if we give the temperature, temperature means thermal energy. So all molecule, all atoms or molecule will excite it, because it will absorb energy from source, thermal energy. It will excite it and it will move to excited state, and randomization takes place. As a result, disorderness of the system going to increases. This disorderness, how much disorderness takes place of a system, that is measured by entropy. And another important thing, in statistical mechanics, we never consider the nature of individual particles. So we consider a sample, and we study the behavior of the system, and we try to find out some thermodynamical parameter for which we can assess the information about the system. Okay, when T is very high, disorderness is very high. Suppose at T equal to 0, probability is 1. That means, and all particles fall in the ground state, then entropy becomes 0. Entropy becomes 0 means it is highly ordered state. Okay, and what is the relation between entropy with probability? So how can you derive? I consider the probability theory. Probability, PR, this formula you have already understood. I have already given probability beta E. This is the probability. This is the probability for non-degenerate system. Non-degenerate system means GR equal to 1. Okay, probability degenerate system I am not considering here, only for mathematical calculation, simplicity. So I can write e to the power minus beta here. Below term is partition function. Okay, so if I take the ln PR means it will be minus ln Z minus beta E. Okay, if I take the mean value of ln PR, why I am taking this one, I will tell you detail. Mean value of Z, it will become Z beta mean value of ER. Why I am not taking the mean value of Z? Because Z is a partition function, it is always constant, and constant mean value is, it will remain same. Why? Because you remember this formula. ln Z, mean value of ln Z. Z is constant, ln Z is also constant. So how can you calculate? Statistical means beta ER ln Z e to the power minus beta ER. This is the formula in statistics, mean value calculation. So ln Z is constant, it will come out ln Z e to the power minus beta ER, e to the power minus beta ER, it will be cancelled, it will be ln Z. So what do you understand? So constant, any constant, suppose 5, 6, 7, 8, the mean value is equal to that value. So it will be this. And next, mean value of energy. Mean value of energy, how can you calculate? Mean value is ER equal to same way, e to the power ER, beta ER, e to the power minus beta ER. So mean value of energy is total energy. So I will write ln Z minus beta mu. Is it okay? Now again we know free energy represent in some book A, in some book it is represented by F. Okay, no problem. Free energy equal to minus kT ln Z. Okay, so kT means 1 by beta ln Z. So I can replace ln Z equal to A beta. Sorry, beta is common, I take it out. A minus U. Is it okay? Again we know A equal to free energy U minus Ts plus mu n, but here I am not considering this part because in plus mu n it will in canonical system, but it is a general free energy, so that's why I am U minus Ts. So it will be what? U minus Ts, it will be minus Ts, so it will be become minus beta Ts. Beta Ts equal beta means 1 by kT, so it will be S by K. Finally, what we will get? S equal to minus K ln PR. Okay, expectation. So entropy. So if we take the mean here, it will be K sum of PR ln PR. Okay. So why it will get? So you see, expectation value of, you can check it yourself, no problem. ln PR expectation value equal to how much? ln PR e to the minus beta ER e to the minus beta ER. Okay. So it will be what? ln P1 e to the minus beta E1. Sum of e to the minus beta E1. ER. Next, ln P2 e to the minus beta E2, sum of e to the beta ER. Dot. Equal to what? This part will give you probability, right? ln P1 is constant. So ln P1 into P1 plus ln P2 into P2. Dot. I can write sum of PR ln PR. Is it okay? That is why I am writing here. But in case of this expression is valid for non-degenerate system. But in case of degenerate system, probability is equal to what? Sum of GR e to the minus beta ER, GR e to the minus beta ER. Okay, this represent G e to the minus beta ER. Do the same calculation whatever applicable to this one. Whatever I have done for this case, same way you have to do the calculation. You will get value as equal to minus K PR ln PR by CR. Okay. This. So this expression is for degenerate system. GR not equal to 1. This expression is equal, non-degenerate means G degeneracy factor is 1. Degenerate means degeneracy factor more than 1. Okay. Now, better you remember this formula. See, S equal to minus K sum of ln PR ln PR by GR. Question comes in the net exam, last net exam. The 5-mark question is very simple question, is based on this one. Another entropy relation, you don't confuse K, ln, omega. Omega is a number of microstep. Okay, and this is the relation entropy and omega. In exam, either question comes from this part and this part. Okay, so I will discuss two questions related to one here, one here. Okay, see. This is entropy, this is entropy, this is number of microstep, this is probability and degeneracy. In some problem, degeneracy and probability is given, then you have to calculate the probability. In some question, number of microstep will be given, then you have to calculate the probability. Or two type of question I will discuss first. So, in the last exam, net exam, question is like that. Consider a system of n particles. Consider a system of n particles. Okay, you listen the question carefully. Consider a system of n particles. Okay, and each particle has 2 microstep or 2 energy level. Microstep means energy level. Each particle having 2 energy state. One is this one, E0, 0 state, one is E equal to E state. Okay, to each particle having 2 microstate, and probability of this state is equal to 1/3, and probability this state equal to 2/3, and degeneracy of this state is G1 equal G0 is 1. 1 means non-degenerate, and this is degeneracy G1 equal to 2. Calculate the entropy. Okay, very easy. So entropy will be minus K. So first one will be P naught ln P naught by G naught plus P1 ln P1 by G1. Okay, this is the formula. Simple question. It is 5 mark question. So minus K, put this value. So P naught equal to 2/3 ln 2 by 3 1/3 ln 1/3 by 2. This is a simple calculation. The rest of the things you will know. Okay, this is simple question related to this. And another question related to other part, number of microstate. And another question I am telling you, if a system composed of an n part, this is a n number of particle, okay, there is a omega number of microstate, then what is the probability? Again I am telling, consider a system of n particle system, and there will be omega number of microstate available. All the microstate equally are likely to be equally possible. But that means all microstate are equal priority. Okay. Then what is the probability? Number of microstate equal to omega, probability equal to 1 by omega. In that case, entropy equal to minus K. K is there, 1 by omega ln 1 by omega. Okay, remember this formula. So another example. You see the question. This question is also comes in the NET exam. So alloy. So this is A, this is B, Na, Nb. Read the question. Consider a alloy. Alloy means it composition of different type of element. Consider alloy, and this alloy composed of 2 different type of atom element A and B, and there is a n number of particle of type A and B number of particle type B. What is the probability? And Na plus Nb equal to n. Okay, and probability of A state equal to what is Na divided by n. I am telling you probability is a fraction of particle occupying in a particular level, and this is the fraction of particle occupying in this state. And probability B state equal to Nb by n. Okay, the number of microstate, how can you calculate? Always remember this is the formula: n factorial, Na factorial, Nb factorial, B factorial. This is the number of microstate available in the system. This is the formula, remember. Then n factorial, Na factorial, n minus Nb factorial. You can replace. Okay, equal to NC Na. This is the number of microstate. Now what is the probability? Entropy K ln omega. This time I have to use this formula because omega I have to find out, because probability is already given, but I am going to give the calculate the entropy from this formula. You will get the same result. Whatever you can calculate the entropy minus K ln PR ln PR. You can calculate this way also, no problem, because PNA is already I have find out. So K ln n factorial, Na factorial, n minus Na factorial. Same question. If you use this equation, you will get the same result. If you use this equation, you will get the same result. It will be K PA. You do it the calculation using Starling approximation. Okay. ln PA plus PB ln pp. You will get the same result. But why I am giving you? Because number of microstate formula this one, and this formula if you calculate, you will get the same result. You can calculate using this formula also, no problem. Very easy. It is 5 mark question. Okay. Now I am going to the density of state. Density of state. Density of state. In earlier video, I have already told you number of microstate. In statistics, it is called number of microstate. In the condensed matter physics, it is called density of state. And it is semiconductor, it is also density of state. And in spectroscopy, number of mode of vibration. Even in blackboard radiation, it is number of mode of vibration. It is there in vibrational study. We will go. The name is different, expression is same. So, what is a now? Because now question is that this density of state is depend on two parameters. One is a dimension, one is a dispersion relation. Okay. So, what is the problem in a question? In books, Pathria book. If you consider Pathria book, Kittel book, Descartes, and Donald Newman semiconductor, and this, if you see this book, all the calculation theory all is given in the three-dimensional space. But in exam, NET or GATE exam, the question often comes either two-dimensional or one-dimensional. So that is why we have to know the density of state formula for 1, 2, 3 dimension. But in exam hall, it is very difficult to remember all this formula. That is why I am deriving a short formula, which is known as the general formula. But this formula is not available in the book. You try to focus on that. Okay. So density of state, you see the general formula. Z proportional to, you can replace, remove the proportional term. E d by s minus 1. This is the general formula you will always remember. In NET GATE exam, 1 or 2 questions related to density of state. But they will not going to ask you density of state for 3 dimensions. They will either ask you 1 dimensional or 2 dimensional. So that is why they want to ensure whether you have understood the theory properly or not. Okay. In statistical physics, you see I am recalling the whole process. Statistical physics, we always consider number of microstate equal to how much? In between P, we calculate total volume of phase space, V into 4 by 3 pi P cube. Okay? Total volume. A cell volume how much? H cube. So it will be and 4 pi V 3 H cube into P square, P cube. Okay, so P equal to, if I replace P equal to P square by twice m, so I can do one thing. I replace it twice m E 3 by 2. So density of state is equal to how much? Is differentiation of this part. Differentiation of D equal to 2 pi V H cube twice m 3 by 2 E half. Okay, one important point you remember. This density of state is valid only for 2 dimensional. Number 1. Number 2, I replace momentum. E equal to P square by. I replace momentum in terms of energy. This expression is valid for classical particle, non-relative history particle, for electron or any other particle. But if I talk about density of state of photon or phonon, then you cannot replace E equal to P square by twice. What will be the dimension? So dimension will be what happened? Dimension will be different for different particle. Dimension, the density of state, it will be different from for fermion and boson. It will be different. How can you define general? That is why I am giving you general formula. Density of state depend on dimension as well as entropy. Now, okay, it is density of state. This is proportional to E half. It is 3D. 3D case I have considered, but I have not given you the density of state for 2 dimensional or 1 dimensional, but I am giving the general formula which is valid for all particles irrespective of phonon, photon, boson, fermion, whatever it is, 1D, 2D, 3D, whatever it is. It is applicable to all systems. Now how to apply? Case 1. Case 1, I will consider non-relativistic particle. Non-relativistic particle. Suppose electron. Non-relativistic particle, where we can replace. I replace equal to p square by twice. I remove this part. Now you can ask me what is a dispersion relation? What is a dispersion relation? E equal to, in electromagnetic study, I assume that you have already studied electromagnetic study omega by c. Have you find this relation? Or E H cos k multiplied H cos omega c. H cos omega means E by c, which means P equal to E by c. Okay. So any relation between wave vector and frequency or omega, angular frequency, or energy momentum relation is known as the dispersion relation. So why it is called dispersion? Suppose if we know the characteristic of Anil Hazarika, you have to describe the all detailed calculation. But similarly, if we know the dispersion relation of the particle in a particular medium, then nature of the particle and characteristic behavior of the particle in that particular medium we can easily understand. Okay, the relation that will tell the behavior of the particle in particular medium is known as a dispersion relation. Okay. For example, if you take a prism, if you give light, then what happens? Dispersion will take place. It will be dispersed. All 7 colors will be dispersed according to Cauchy theory, Cauchy refractive index wavelength theory. This is a dispersion relation. So dispersion relation will tell the behavior of the particle, and this dispersion relation will be different for different particle. For phonon it will be different. For electron it will be different. So accordingly density of state will be different. So density of state, that is why we have to understand the question whether it is phonon, whether it is photon. So that accordingly density will change. So that to avoid that confusion, I am giving a general formula. So now what is the D? D is dimension. Okay, do not confuse dimension. And S is a integer value from the power of K or momentum. Okay. Now this is a non-relativistic case. E equal to is proportional to omega, right? So I am not writing here. E equal to H cos k square by twice m. Okay, that means proportional to k square. This is power. This is S. S equal to 2. In this case, that means S equal to 2, right? So in this case S equal to 8. Now you see for 3-dimensional D equal to 3, S equal to 2. So G equal to G proportional. I remove proportional term, that's why I put constant A. E 3 by 2 minus 1. Okay, A E half. Whatever I have derived using that one. Is it match? I have derived this formula, right? Z equal to twice pi V H cube twice M E 3 by 2 E half. Is it match? C, match. Number 1. Number 2. 2D system. D equal to 2, S equal to already 2. So Z is equal to 2 to 1, a constant. Okay. And 1D system, G is equal to A e to the power minus half. Okay. This is for any particle following this dispersion relation. Clear? One question last in an example. This question is like, which of the following figure exact representation of density of state function in 2 dimensions? One function is given like this, one 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 is given like this. This is G D by E. Sorry. Which one is correct? In 2 dimensional, this is constant, so this is correct. So this way you have to find out in example. So number 2, case 2. Again, carefully you study it. This is the basic part, okay? You carefully try to understand. Once you understand this part, rest of the whole thing you can easily understand. And most of the student I encounter in my life, so they often confuse with this confuse with density of state, and they don't know which is applicable, what is applicable. Okay, case 2. Case 2, any other particle, suppose photon particle, photon or phonon particle. So previous one is a classical particle, non-relativistic particle. It may be Bose-Einstein statistic, it may be Fermi-Dirac statistic for electron. But in case of Bose-Einstein particle, for example, phonon and photon, what is the relation energy versus energy and momentum? So E square, you know the P square C square M naught square C to the power 4. This is the relativistic relation. Suppose for photon, some response is 0, this part will be 0. So this means E equal to PC, right? So E means A cos omega. You can replace A cos omega equal to E equal to how much? A cos K C. So E is directly proportional K, power is 1. So in this case S equal to 1. Okay, S equal to 1. And for D equal to T, Z equal to how much? Z equal to how much? This is A constant, D equal to T minus 1 equal to 1, AE2 square. Okay, and Z equal to 3 dimension, it is for 3D. 2D it is 2, 1, 2, E1. And it is constant, so 1D, 1, 1, 0, constant. It is 2D, it is 1. Okay, what is the difference between basic? Why it is important? Suppose, why is so important? Whenever we consider number of phonon in a two-dimensional crystal, then what you have to multiply? Density of state, D into average, into what? Into average number of particles. Okay, average number of particles equal to Z D into Fe, distribution function. Why it is distribution function? If it is phonon, then it will be Bose-Einstein statistics, Bose-Einstein distribution function. If it is electron, then it will be Fermi-Dirac statistics, Fermi-Dirac function, the probability function you have to use. Why it is, why I replace n cap equal to Fe? That is important. And density of the state you have to replace according to the nature of dispersion relation. Sometimes you have to replace this one, sometimes you have to, if it is 2 dimensional, you have to replace this one, and if it is 1 dimensional, you have to replace this one. Okay. And if it is electron, then density of previous case you have to replace. Now, why it is dispersion? Why it is Fe? That's what I mean. Now, why density of state is important? Why important? Why important? You see, have you remembered this black body radiation calculation? N is equal to n e to the minus beta n e beta minus n e beta. Have you remembered equal to what? Equal to e to the power e by kt minus black body radiation calculation. So e to the power e minus mu by kt minus 1. It is what? Why I am putting mu? Mu is 0 in black body radiation, photon, photon. So that's why I put mu. It is what? Maxwell-Boltzmann distribution function, Bose-Einstein statistics. Is it okay? Now what happened? This is occupation number. The average number of photon equal to Bose-Einstein. It is a probability number. That's why I told you. And this question you have seen in statistics, in condensed matter physics, in semiconductor. Have you seen, whenever you consider the number of particles in conduction band, how to calculate? Then we have to calculate Z, DE, okay? Then average number of photon. And this equal to what? Fe. Z, D, F. So this formula you have often find it in books, but nobody understand. Reason is that density of state into Fermi function, it will give total number. And if you calculate total n, G D F. Now if it is electron, then you have to use the electron dispersion relation formula, density function. If it is two dimensional, then you have to replace two dimensional case. Okay. Okay. Now suppose if you want to total energy, if you want to measure, what is the total energy? It is density of state. This is the density of state, must be there. GD into what? Average energy. Okay, average energy if you multiply. What is the average energy? I have already told you that in the blackboard radiation calculation. It will give H cos omega nk. H cos omega means E average energy means F. Is it okay? So this is the formula. I have already told you in the previous case. So if this becomes G D into E into F. If you find the total energy, you have to do integration. G D E F. That is why we always multiply with Fermi function with energy. If we E average energy multiply with density of state function, we will get the total energy. Average number with density function, you will get the total energy. What we can understand, is it not similar? Suppose, to make you more better way understand, in this room there is a 10 bench. Okay, so every bench occupied by 5 students. How many number can occupy in center? 100 into 500. Similarly, same rule play by the density of state. Suppose another example I am giving. This is electric flux. Electric flux. If I take a sheet of paper, A4 size paper. Now, electric flux is there. Suppose wine is blowing from this side to this side. Now, my question is that how much air flowing through my A4 size paper? Then what will you do? Suppose this is electric flux. This is electric field vector. Flux equal to integration E dot ds. ds means area of my plate. ds, area of my plate. It will get the total flux flowing through this area. Okay, I am not focusing that part. This role is played by the density function. Total average number into density function. Total number of particles in a cavity in case of blackboard equation. Total volume. Volume into average number. Total number of particles in that volume. Similar with density of state play the same. And density of state depend on dispersion relation. Dispersion relation tell the nature of the particle. Okay. Another question I am telling you why it is so important. In NET exam last year, it is 3 mark question comes, a very easy question. So question is like that: the specific heat at low temperature of particle following dispersion relation E is proportional K2. Okay. Is which of the following is correct? Specific heat proportional at low temperature 1, 2 is T 3 by 2. Number 2 T square. Number 4 T. Which one is correct? Passive heat at low temperature. Apart from electronic contribution. Electronic contribution is excluded. So which of the most of the students get this answer? And this is a wrong answer. Okay, passive heat divide theory. We often find T cube blue. Passive heat at low temperature, it will be T cube. But this according to this rule. But this question does not tell that this is a passive heat solid at low temperature due to form. It is not mentioned. They mention the passive heat of crystal, 3-dimensional crystal of particle which follow the dispersion relation. That is the question. Okay, and this answer is wrong. This answer is correct. But in Pathria, in Kittel book, we often find the passive heat proportional to T cube. Okay, this rule we have already found. But this rule is valid only for phonon. Remember, but phonon is boson. There is many other particle. There is many other particles which are also boson, but do not follow the dispersion relation followed by phonon. Okay, that means what? Specific it also depend on the dispersion relation as well as dimension. So that is why I am giving you the general formula. You always remember specific is proportional to T d by S. This is the general formula. Always remember. You will never find in the books. So I derived this general formula. I have calculated the specific in 3-dimensional, specific in 2-dimensional for phonon, any other particle. So I observed the variation. So specific at low temperature this is the formula. So phonon, as I have already shown, E equal to P by C. PC. That means what? E is proportional to K1. Okay, this is S equal to 1, and 3-dimensional crystal Cv equal to how much? Proportional to T3 by 1 equal to T cube. Is it okay? It is 3D. But it is 2-dimensional crystal T3 by 2 by 1 T square, and 1D crystal T, and this 1D crystal according to the dimension. Okay, it is T cube for 3D. 2-dimensional it is 2, 3-dimensional it is 1, and which is equal to the electronic contribution of specific. What I am telling you, this specific it not only depend on dimension but also on the dispersion relation. Okay, and similarly density of state not only depend on dimension but also depend on dispersion relation. Dispersion relation tell the nature of the behavior of the particle in particular material. Okay, we will study detail. Now partition. Why it is so important? Why I am giving you this density? Because I have given you partition function in discrete system, but I have to discuss the partition function in continuous system. But continuous system in 3-dimensional. But in the Pathria book, that is discussed in 3-dimensional system. But they are not discussing 2D and 1D. But I am giving you the general formula. So from where you can easily find, without doing calculation, you can find out the specific for 1D. Partition function for 1D and 2D also. So what is a partition function? I give you the general formula is the integration e to the power bs d omega d. Okay, this is the general formula of partition. What is the d? D is the dimension. Okay, in this is s cube e to the power minus bs. It will be d cube omega 3d d cube omega. D cube omega means what? S cube minus bs d cube omega d cube p d cube q. This is okay. This is for 3D. If it is 2D, then a squared. If it is 1D, then it will be s. This is 1D. This is one formula. Another formula you can replace the partition function e to the power minus beta is into GED. So another previous one is what? D equal to 1 by s cube is the e to the power minus b is omega. This is phase space volume using phase space. I am here. This is density using density of part. This is two different ways you can calculate the partition function. So I will give you the two different ways so that you can easily understand the partition function. Okay. First I will do general term using space volume. Then I will go to the part using density of state. Okay. Suppose consider a system of n particles, n gas particle, ideal gas suppose, and there is no interaction. N particle, there is no interaction. Hamiltonian will be what? P square by twice m plus 0. 0 means potential, no interaction, so potential is 0 equal to P square by twice m. So don't confuse AC is represented as a total energy of the system. You can replace E, no problem. So partition function, and all these particles are non-distinguishable, indistinguishable particles. So what is a partition function whole system? 1 by n factorial. Okay, I have already told you partition function for indistinguishable particles. Integration. Okay, e to the power. This is three-dimensional. I am considering. Okay, e to the power minus b is it okay? N d cube omega. Okay, then okay, d cube omega means 1 by n cube 1 by h to the power 3, okay, e to the power minus bh. d cube omega, there is a n numbers of particle, you have to find out the partition function for n numbers of particle, and there will be n volume, n numbers of volume. That is why it is represented I equal to 1 to n d cube pi d cube qi. So partition function is a product. This is product sum. So there will be that you can replace this like that 1 by n factorial. Okay, I can represent 1 by h cube 0 to infinity. I am not putting the limit, no problem. D cube p d cube q to the power n. So there will be n integration will be there. So is this c, there will be an integration dx, suppose dx, I can replace x dx to the power n. Is it okay? Same way, there is a n number of particles, so there will be n numbers of volume, n numbers of integration. So I can put a n numbers. Okay. So here this term, see this term Hamiltonian is p square by twice m. There is no dx, dy, dz. So this term will come. This term will give you what? 1 by n factorial. This term will give you volume, right? H cube integration e to the power minus p square by twice m kt, okay, into d cube p to the power n. Is it okay? Clear up to this part? Now what is a dp? d cube p. So omega is the total volume. Omega total volume of phase space. Vp into vq. Vp means what? 4 by 3 pi d cube, and Vp means V, volume of rectangular space. So here, so dVp means this, sorry, dVp means 4 by 3 pi p cube. It is volume of momentum space, right? So dVp means it will be 4 pi p square dp, right? So this dVp is d cube, this equal to d cube p. This represents this one. Okay, clear? This equal to 4 by 5 d cube. Now you have to replace this one. So partition function will be 1 by n factorial v by h cube integration 0 to infinity e to the power minus p square by twice kt 4 pi p square dp to the power n. Is it okay? Now you tell me, you have already studied gamma function. Can you do the gamma function using equation? It will be n cube v by h cube integration 4 pi is there, integration 0 to infinity p square by twice m kt p square dp. So I am not going to give you the gamma function calculation, but what to do? Gamma function equal to gamma n plus 1 equal to 0 to infinity minus x to the power n dx. This is the gamma function formula. So you take this, consider this part equal to x, and then you using this. Then another is a gamma n plus 1 equal to factorial n, gamma half equal to root pi. This is the property of gamma function. Once you take this value and put this value, you will get the result. This is the standard integral, you will get a constant. Gamma n plus 1 equal to n gamma n. Use this formula. I am not going to give you the calculation because I am going to discuss the numerical problem where I am going to do calculation, gamma function calculation. Okay. And using gamma function, you will get this value 1 by factorial n v by h cube 2 pi m kt 3 by 2 to the power n. Okay. Now this is the partition function for whole system in 3-dimensional system, not in 2D, not in 1D. Because in 1-dimensional system I have to again calculate using the density function, it will be different. In 2D I have to calculate. So in order to avoid, I am giving the general formula partition function. 1 by n factorial is there. Okay. Then VD, D is stand for dimension. Okay. H D, right? 2 pi m kt d by 2 to the power n. Okay. So for TD you see I have derived the general formula. Okay. And in case of suppose you want to calculate the question will be like this. Consider system of ideal gas in two-dimensional box. Okay. Of area L cube. Then calculate the partition. Some question comes in the NET exam last year. Two-dimensional partition. So this case for D equal to T, V it will be T. VQ means do not V into V. It's not like that. VQ means volume in 3 dimensions. It will be represented by V or LQ. Okay, if it is squared. Okay, so I represent VD. VQ means volume in 3D. So in 2D system, D equal to 2 V square. V square means what? Volume in 2 dimensions. It will be area. Okay. In 1D system, D equal to 1, it will be V1. V1 means what? Volume in 1 dimension. There will be no volume in 1 dimension. It will be L. So it is for partition function for 1-dimensional 1D case cell. You just remember 1 by n factorial. It will be what? L. Okay. It will be what? H. Okay. It will be what? Twice m k pi kt. It will be 1 by 2 to pi. Okay. And inside part is partition function for single particle. And why I am keeping to the power n? Because it is partition function of whole system. So in the previous class, this is the general formula always here. In previous class, I have given you the partition function of the whole system z to the power n. So same way it is done. And another question: if the system is composed of distinguishable particles, remove n factorial. But remember, this n factorial does not affect any thermodynamical parameter calculation. Okay. So you may require okay. Now another point is I have not tell you the partition function how to calculate that using density step function. Density step. So partition function is calculated using density function. So I am using density function. So 0 to infinity e to the power minus beta e. So initially I have written H. H is nothing, that is total energy. I am writing here E. No problem. You can replace P also, no problem. Then e to the Z D. So what will I will put Z equal? It is, if it is 3-dimensional, I have to put 3-dimensional density of cell. If it is classical particle electron, then according to dispersion ratio. So Z equal to what? Z for electron. This is a classical particle. Okay, not considered a boson on phonon. Okay, so it is classical particle that follow equal to P square by C. It is non-relativistic. In this case, A E d by s minus 1. In 3D, s equal to 2. So A E half. Okay, A E half equal to A means what? We have already calculated twice pi V A square S cube twice m 3 by 2 E half. Okay, this is the formula. So I will put here. Why I am not putting 1 by h cube? Because h cube is already inside. So that's why I am not putting here h cube. Okay. So it will be 0 to infinity e to the power minus beta e. It will be I will directly put it will be how much? Twice pi v h cube twice m 3 by 2. Okay, 0 to infinity e to the power beta e, and it will be e half d. Okay, Using gamma function, I will do the calculation so that you can easily do rest of the calculation. So I put this equal to beta E equal to x. So d equal to how much? Dx by beta. E replace here. Twice by v is cube. Twice m 3 by 2. Okay. Limit will not change. X equal to 0. E equal to 0. Oh, sorry. E equal to 0. X equal to 0. E equal to infinity. X equal to infinity. No need to change the limit. E to the power minus x. It will be what? X means x by beta half. Right? Half. Okay. D means dx by beta. Clear? So that equal to 2 pi v is cube twice m. So beta it will be 3 by 2. I can replace beta twice m by beta 3 by 2. Okay. E to the power 0 to x, e to the power x to the power half dx. So I have already told you. I have told you gamma n plus 1 equal to 0 to infinity x to the e to the power minus x to the power n dx. Here it is half. So equal to how much here? It is big. This equal to how much? Here n equal to half. Then it will give what? Twice pi v is cube. Twice m beta half 3 by 2. It will be gamma 3 by 2. Okay. What is the gamma 3 by 2? You remember, I have already given you gamma n plus 1 equal to what? N gamma n. So gamma 3 by 2 means equal to gamma half plus 1 equal to half gamma half. Okay. So gamma it will be twice pi v is cube twice m beta 3 by 2. Okay. This is what? Half into gamma half. Gamma half equal to how much? Root pi. Remember. Root pi. So pi is there. 2 to cancel. It will be pi and it will be v by is cube twice pi m beta 3 by 2. Is it okay? Beta means what? Beta means b by is cube twice pi m kt 3 by 2. Okay. This is using gamma function. So you always try to understand the gamma function. Now you see. This is, remember, this is the partition function for single particle. So what is that? I have given you general formula. General formula is what? 1 by n factorial. Okay. Vd is d 2 pi m kt d by 2 n c. Is it maths? See. T equal to 3. Okay. V cube equal to V volume in 3 dimension. Correct. Is d equal to 2, and this is for single particle. There is z equal to what? N factorial 1 factorial means 1. So this part not equal. The power is not equal because n is 1. So it will be what? V is twice pi m k t 3 by 2. C. Maths. Result is maths. Okay. 2-dimensional distance. Now it is how to calculate in 2 dimensions. Suppose you want to calculate partition function in 2 dimensions. See, difference you see. I am not going to give the calculation. Difference you see. Integration e to the power minus beta e z d d. Okay. Then into this dimension g is equal to d proportional d e d by s minus 1. 2 dimensional. For classical particle s is 2, dimension is 2, 2 to 1 is constant. That means e to the power minus beta e, a constant, suppose ad. This constant will come out, integration e to the power beta e d. Okay. Now what is the value of constant? How can you calculate? How can you calculate? This is a simple integration. E to the power beta e 0 to infinity equal to a e to the power minus beta e minus beta 0 to infinity. You can do the calculation. Okay. This is for 2D case. Now you have to find out what is the value of it. So that things, how can you remember? How can you do that integration? So to remember two-dimensional, another general formula which is often used in condensed matter physics and solid state physics and semiconductor all other part. Another general formula, number of microstate. The number of microstate. General formula I am giving you d by k. K is a moment of space, or equal to Lx, Ly, Lz twice pi d integration d to the power dk. Okay. And if you replace in momentum space, then Lx, Ly, Lz twice pi power d, then 1 by h cross d into dp. This general formula for number of microstate. If you remember this formula, then you can find out. And if you remember that general formula v into 4 by 3 pi p cube, that is also okay. Then you see, this is total volume equal to how much? It will give, this is what? V by twice pi d 1 by h cross d. This is what? Momentum space, d-dimensional space. If it is 3-dimensional, so it will be cube d k. See, now you see, this is the general formula. You always remember. Suppose for 3D, d equal to 3. So number of microstate equal to how much? V by 2 by 3, right? 1 by h cross cube. It will give what? This p, sorry. 4 by 3 pi p cube. Okay. Then this will cancel out. This will cancel out v by h cube. This is 4 pi v 3h cube p cube. Is it okay? This is general formula. And in statistics we calculate like this, na? Is equal to how much? V into 4 by 3 pi p cube into h cube. Same formula we are getting. Is it okay? Now, in 2D case what happened? 2D case, number of microstate, it will be Lx, Ly, only two terms. 2 pi square. Okay, 1 by d for square, d square p. Okay, so d square p means this will have area vector. Then this will cancel out a square. Okay, area. And this is what? D square p means integration of dpx integration, because x y dpy. So what will you get? A by a square into p square. Okay. So p square equal to what? A by a square twice me, right? Replace p. This is okay. So this is number of microstate. Now z equal to into d. It will be what? This is by d equal to what? A by e square twice m. Okay, that means density of state 2-dimensional is constant. Now you verify whether your answer is correct or not, because as a formula I have given it, proportional to E d by s minus 1. So d equal to 2, s equal to, for classical particle, 2. So G is equal to what? Constant e to the power minus 2 by 2 minus 1 equal to A constant. This is A, do not write A, otherwise confuse C constant. Set. Here it is constant, here it is constant. This constant equal to this star. Okay? And similarly this way you can calculate for 1D. 1D density of state. 1D density of state, how can you calculate? See, this is what? 1D I will calculate L only. X, Y, Z, any one of these. Twice by 1. 1 by D is cos 1. D1 P. Okay? Equal to how much? H plus H cancel. L by H. It will give what? Only P. P means what? P means twice ME. Okay? L by H twice M half. So number of microstate equal to given? Z equal to given? Equal to D E by D equal to what? L by H twice M half E half cancel half E minus half. This is, that means this is a constant, and this equation L by 2 is twice M half E minus half. Okay, this is a, you can verify Z equal to proportional E D by S minus 1. Okay, 1D 1 2 half minus half is equal to A E to the power minus half. Okay, clear? So this way you have to calculate. This expression is given in the Kittel book whenever we consider analyze the Billion-Joule calculation. And say, I think it is chapter number 4, Fanon calculation. Yes, specific theory. Divide theory is, this expression is given in Kittel book, but they have not derived that one for where they came. Okay, this way we have to remember. It is easy way to remember. So thank you. So I am not going into detail. So in the next class I will give you the how to calculate the partition function, thermodynamical parameter, for example mean chemical potential, mean energy, pressure, volume from partition function. Okay, I hope you will understand. If you have any query, I will give the phone number, you can send SMS. Okay, if you necessary I can give you the soft copy, because I have made all the soft copy for NET exam and competitive exam. Okay, thank you.